In the last videos, we learned about the fundamental rules of modular arithmetic. And today, we're going to try using these rules that we learned to creatively solve these problems. You're going to notice that many of these problems involve finding the remainder. And these are the type of problems where it is most appropriate to use modular arithmetic in. Because modular arithmetic is all about remainders after all. So our first problem is to find the remainder when this sum is divided by 3. So we can just go ahead and add all these numbers and then divide by 3 and find the remainder. That's pretty easy, but it's not really elegant. It's not really interesting. It's kind of boring. So we can actually solve this problem using modular arithmetic in a really interesting way. So I recommend you to pause this video and try out the problem yourself, and I recommend you to use modular arithmetic to solve this problem. And you're back. So firstly, we can use a rule in modular arithmetic to easily solve this problem, which is the addition rule. Oops, let's write that clearer. The addition rule. So the addition rule states that if A is congruent to C mod M and B is congruent to D mod M, then A plus B is congruent to C plus D mod M. So basically this is saying that the sum of all the numbers on this side is congruent to the sum of all the numbers on this side mod any number. So let's keep that in mind because it's going to become pretty useful when solving this problem. So first let's list out all these numbers. So 123, 234, 32, 56, oops, let's write that here, 56, 22, and 78. And we're gonna find all the, for each number, we're gonna find its remainder when it's divided by 3. So we're gonna be finding the number that, for each number, we're gonna find the number that each number is congruent to mod 3. So firstly, 123 is a multiple of 3, so it's congruent to 0 mod 3. And 234 is also a multiple of 3, so it's congruent to 0 mod 3. And 32 has a remainder of 2 when divided by 3, so it's congruent to 2. And 56 has a remainder of 2 as well when divided by 3, so it's congruent to 2. And 22 has a remainder of 1 when divided by 3, so it's congruent to 1 mod 3. And 78 is also a multiple of 3, so it's congruent to 0 mod 3. So we got all our remainders for each of these numbers. And here comes the addition rule. So the addition rule states that the sum of all these numbers is congruent to the sum of all these numbers mod 3. Oh, wait a sec. The answer is asking for something about this sum. So this might be actually pretty useful in solving this problem. So let's try it out. So the sum of all these numbers is congruent to the sum of all these numbers mod 3. So 123, 23 plus 234 plus 32 plus 56 plus 22 plus 78. Oh, I got that right in the center. That's good. It's congruent to the sum of all these numbers. 0 plus 0 plus 2 plus 2 plus 1 plus 0. Oops, let's write that clear. And this adds up to 5. And 5 has a remainder of 2 when divided by 3. So 5 is congruent to 2. So this is congruent to 2 mod 3. So we can conclude from this that this sum is congruent to 2 mod 3, which means that this sum has a remainder of 2 when divided by 3. So the answer to this question is 2. That's pretty neat. So instead of so this sum this calculation was much easier than this calculation. So we can see here that instead of boringly adding all these numbers, we just easily solved this problem using modular arithmetic in a quick and also pretty interesting way. So we can see here that modular arithmetic is pretty useful in math problems. So we kind of got a basic understanding of how to use modular arithmetic in math problems. So let's move on to our next problem. So let's erase this first. Ching. And get rid of this problem and go into the next one. So, similar problem, but it's multiplying. So find the remainder when this product is divided by 3. So you can just actually just go on and solve this product, which will be pretty tiresome and frustrating. But again, you can use this beauty to actually find the answer to this problem pretty easily. So I recommend you to pause this video and try out this problem yourself using modular arithmetic. And you're back. So we can use the multiplication rule in modular arithmetic to easily solve this problem. So the multiplication rule. The multiplication rule states that if A is congruent to C mod M and B is congruent to D mod M, then A times B is congruent to C times D mod M. I hope you guys all remember that. So what this tells us is that this product of all the numbers on this side is congruent to the product of the numbers on this side, mod M. So let's again keep that fact in mind and try solving this problem using this rule. So it's actually in a really similar fashion to the problem that we solved previously. So let's list out all these numbers again. 23, 49, 235, and 13. So so we're going to be looking at, for each number, we're going to be looking at its remainder when it's divided by 3. So we're going to be looking at, for each number, what is congruent to in mod 3. So 124 has a remainder of 1 when divided by 3, so it's congruent to 1 in mod 3. And 134 has a remainder of 2 when divided by 3. So it's congruent to 2 mod 3. And 23 has a remainder of 2 when divided by 3. So it's congruent to 2. And 49 has a remainder of 1 when divided by 3. So it's congruent to 1. And 235 is congruent to 1 mod 3 because it has a remainder of 1 when divided by 3. And 13 also is congruent to 1 mod 3 because it has a remainder of 1 when divided by 3. So we're done with this. And again, using the multiplication rule, we can see that the product of all these numbers is congruent to the product of all these numbers, mod 3. So let's try that out. So 124 times 134 times 23 times 49 times 235 times 13. Did I get all the numbers? Yes. It's congruent to 1 times 2 times 1 times 2 times 2 times 1 times 1 times 1. And this simplifies to 4. And 4 has a remainder of 1 when divided by 3, so this is congruent to 1 mod 3. Neat. So we can conclude from this that this product is congruent to 1 mod 3. So it has a remainder. So this entire thing has a remainder of 1 when divided by 3. So that's our answer, 1. So pretty similar. So this solution was pretty similar to the solution for the previous problem. So we're getting a clear understanding now of how to use this kid in our problems. So let's move on to our last problem. So erase this, and then move on to our next one. Find the remainder when 8 to the 20 is divided by 7. Well, if you got, it's going to be pretty hard. It's going to take a lot of time to actually find the value of this. So I don't recommend you to actually try finding the value of this. So again, we can use modular arithmetic to easily solve this problem without even having to calculate the value of this. So again, I recommend you to pause the video and try this problem out for yourself before I tell you the solution. So you're back. And this time we're going to be using the exponentiation rule. The exponentiation, did I spell that right? I hope so. The exponentiation rule. So the exponentiation rule states that if a is congruent to b mod m, then a to the power of k is congruent to b to the power of k mod m, where k is any non-negative integer. So how is it going to help us solve this? We can see here that this is about the exponents and this is about the exponents. So, well, we can kind of see that it might help, but let's try it out first. So, firstly, 8 is congruent to 1 mod 7 because 8 has a remainder 1 when divided by 7. Then what about 8 to the 20? 8 to the 20. Well, according to the exponentiation rule, if 8 is congruent to 1, then 8 to the 20 will be congruent to 1 to the 20 mod 7. And 1 to the 20 is basically just 1. So 8 to the 20 is just congruent to 1 mod 7. So 8 to the 20 has a remainder 1 when divided by 7, and that's our answer. Well, that was pretty easy. So that's how useful modular arithmetic is. It makes solutions so easy and elegant and really interesting. So that's why I really like this topic. So I hope you guys got a clear understanding of how to use modular arithmetic effectively in math problems, and thanks for watching, and see ya in my next videos.